In this video, we're going to talk about part 1 of SL and HL math, which is going to be algebra, and to be more specific, we're going to talk about sequences and series. Now, this video will probably have a few parts where I will talk about the arithmetic sequence and series independently, then geometric, and then some word problems regarding both, which can involve compound interest, finding future values, and etc. So, the good place to start is to understand what a sequence is, right? A sequence is just numbers that follow a certain pattern. For example, I have 2, 4, 6, 8, dot, dot, dot. I put dot, 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 assuming this is going to be an infinite sequence, but we can also have finite sequences, which means then, in that case, we will know what the final value is. Okay, but I'm going to leave it like that for now. So, can we notice any pattern here? Can we notice any pattern here? We see 2, 4, 6. We see that to get the next number, all we have to do, add 2 to the previous one. Okay, so we have ourselves a sequence. There is numbers and they follow a certain pattern. Now, this is an increasing sequence, okay, but it doesn't have to be. We can also have a decreasing one. For example, 9, 6, 3, 0, etc. And if you notice, here we have -3, -3, and -3. Okay, so we can safely say the difference here is going to be equal to 2, and the difference here is going to be equal to 3. Now, once there is a pattern, that means we are able to guess what the next element is going to be, right? Now, all we have to do, for example, in the first one, to find the fifth element, I just have to add 2 to the last one. So, I'll say 8 plus 2, that's going to be equal to 10. And at the bottom here, 3 minus 3 became 0, and 0 minus 3 is going to become -3. So, we're not only able to understand what the pattern is, but obviously we're able to find further values. Okay. Now the question comes in, what if somebody asks us to find the 10th term in the first sequence? 10th term in the first sequence. Obviously, since we understand the pattern, we can just keep writing, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let me see if that's 10. Yes, that is the 10th term. So 10th term is 20. Now you noticed it took me some time, but it wasn't that slow. Now, if somebody asks me for 100th term, then we are in a pickle because it takes way too long to actually write everything down. So what do we have for this type of cases? We have a formula, as you can see here on the top, and it's called nth term of an arithmetic sequence. Okay, that means to find the nth term, meaning 100th term, we can find, or we can use rather, this formula. So let's explore this formula. What do we have here? We have un is equal to u1 plus n minus 1 times d. Okay, so what is the d here? D is what we talked about, it's a difference between the terms, which in the case that we are working on, this 2, 4, 6, 8 is going to be 2. So we have d is equal to 2. N is, we're looking for 100th term, so n is going to be 100. And u1. Now what is u1? u1 is called the first term of the sequence, first term. So in this case, u1 is going to be equal to 2. Okay, so that means we can now finalize this calculation. So that's going to be equal to 2 plus 100 minus 1 times difference, which is 2. And that's going to be equal to 2 plus 99 times 2. And that's going to be 2 plus, I want to say 198, right? And that's going to be 200. So the nth or 100th term in this sequence is going to be 200. Now let's take a look. So we found that in 2, 4, 6, 8, we have D, which is 2. And we also found, for example, N, when N was equal to 100, UN was 200. Okay? Now the question comes in, what is the sum of first 100 values? That's where the series come to play. So a series means sum of arithmetic, well, in arithmetic series means sum of arithmetic sequences. So not only I'm looking for the nth term here, I'm looking for the sum up until and including that term. Meaning, for example, let's simplify this a little bit. If I'm looking at S4, meaning the sum of first 4 terms, that's going to be 2 plus 4 plus 6 plus 8, which I believe is, so this is 10, this is 10, so this is going to be 20. And now the question comes in, what is going to be S100? Obviously, again, we can write it manually, but that's going to take way too long, and that's why we're using formulas. Okay, what do we have here? We have Sn equal to n over 2, 2u1 plus n minus 1d, and we have another formula, which is n divided by 2u1 plus un. Now, why do we have two formulas here, and are they related? Now, they are very related. Meaning you can get one from the other. Okay, so let's see how. For example, I'm going to delete this one for now. Let's say Sn is equal to n divided by 2 u1 plus un. Now, when there are cases where one of these are more preferable. Now, what is the scenario? If you already know what your un is, un, in our case it's u100, was equal to 200, right? If you know what your un is, then this formula is easy, right? So if I'm looking for S100, this is going to be equal to 100 divided by 2. My U1 is 2 plus UN, which is 200. And then all I have to do is just calculate this value. That's going to be 50 times 202, and whatever that's equal to. Okay? Now, what about the other formula? Other formula says Sn is equal to n over 2. Now, if you notice, if we take the first formula, this one here, u1 plus un, and for un, we put the formula of un. What do we get? We get u1 plus, I'm going to put it in the bracket so we know what we did, u1 plus n minus 1 times d, close the bracket. I'm going to try to simplify it a bit further. So this is going to be 2u1 plus n minus 1 times d. Now, as you see, we just got the second Sn formula, n over 2, 2u1 plus n minus 1d. Now, when is this formula useful? When you don't know what your un is. For example, let's say I'm looking for S50. Okay, so I will say 50 divided by 2. I know what my u1 is, so 2 times u1 is 2, plus 50 minus 1 times 2. Okay, that's going to be 25. Multiply 4 plus 49 times 2. That's going to be 25 times 4 plus 98, I believe. And that's going to be 25 times 102. So whatever the answer to that. Okay? That's going to be our S50. So what did we learn? The moral of the story. We have UN formula to find the nth term. As long as we know what our difference is and what our U1 is, then we can find the nth term. And if we know our U1 and if we know our D, we can also find sum of n terms. By sum, I don't mean S-O-M-E, I mean S-U-M, sum, accumulation. Sum of first n terms. Okay, now sum formula again had two variations. And we said if you already know what your UN is, you can use the second version, right? This one right here, if you know your UN. And if you don't know your UN, then this one will be, let's say, case 2 and case 1. Will be much easier to use. All right? So that is arithmetic and sequence and series in a nutshell. I think it will be great to do some examples, so let's do some. An arithmetic sequence has U1 equal to 40, U2 is equal to 32, and U3 is equal to 24. Find the common difference. All right, so we've got 40, 32, and 24. And we don't know the rest. Okay, find the common difference D. Now, you will be tempted to look at the numbers or sequence and try to come up with a pattern, which is what you should do. But the easiest way to find the difference in any sequence is to subtract next term from the previous one. What do I mean by that? So difference will always be equal to UN minus UN minus 1. Or you can say UN plus 1 minus UN, meaning next one subtract the previous one. So in this case, let's say 32 minus 40, which is going to be negative 8. Now you could also find that out from 24 minus 32, which is also going to be negative 8. So if it is a sequence, obviously the difference shouldn't change because we are following some sort of pattern. So the difference here is going to be negative 8. Negative 8. Find U8. Okay. Now once you know what your D is, and if you know what your U1 is, then you're golden. You can find any UN, right? Using the formula that we have. So the formula is U8 is equal to U1 plus N, well, let me go back here and write it a bit more openly. So N is 8, 8 minus 1 times the difference, which is negative 8. So do we know what our U1 is? Yes, we do. It's given 40. So 40 plus 8 minus 1 is 7. 7 multiplied by negative 8. That's going to become 40 plus negative 56. And that's going to be equal to negative 16. So U8 is going to be negative 16. Last one, S8. Again, this is a good example because we said we have two formulas for Sn, right? And if you already know what your Un is, which in this case, U8, then the second formula might make your life easier. So let's use that. N is 8, so 8 divided by 2. Multiply U1, which is 40, plus Un, which in this case is U8, negative 16. Close the bracket. 8 divided by 2 is 4. 4 times 40 minus 16, right? A little bit of algebra here. 4 multiply 24, if I'm not mistaken, and that's going to be equal to 96. 96. There you go. An arithmetic sequence is given by 3, 5, 7. Write down the value of common difference. Again, we're going to use the rules that we learned to find the difference. We take next value minus previous value. You don't have to write that all the time, obviously, just because we're just learning it. So it's going to be, what do we have? Next one, we can take 5 and 3. That's going to be 2. Or we can take, like I said, 7 minus 5, which is also going to be 2. So our difference is 2. And what's happening here? This is an increasing sequence. Every time we add 2, so the next one is going to be 9, and then 11, then 13, etc., etc. Okay? Now, B says find U10 and S10. U10, we already know. U10. That we have a formula, right? So U1 is 3 plus n minus 1, which is 10 minus 1, and the difference is 2. That's going to become 3 plus 9 times 2, and that's going to be 3 plus 18, which is 21. And S10, again, since we already know what UN is, in this case 21, we can use the second formula for Sn. That's going to be 10 divided by 2 multiplied by U1, which is 3, plus UN, which is 21. And that's going to become 5 multiply 24. And if I'm not mistaken, that should be 120. So U10, 21, S10, 120. 120. And now, last piece, given that UN is equal to 253, find the value of N. Now, usually, they gave us N, like B1, and we had to find UN, but this is opposite of that. So we're given UN, but we don't know what N is. So all we have to do again, use the same formula that we have. So what's the formula again? UN equals to U1 plus N minus 1 D. Now in this case, UN is equal to 253. We don't know what N is, but we do know what U1 is, which is 3. We do know what D is, which is 2. So we just have to solve this linear equation. I'm just going to open the bracket here. 3 plus 2n minus 2. Further simplify 2n plus 1. So 2n plus 1 equal to 253. Then 2n is going to be equal to 252. And n is going to be 252 divided by 2, which is, let's see what that is. 1, 2, 6. 126. 126. So, what we learned from this one is the 126th term is going to be 253. Consider an arithmetic sequence 2, 6, 10, and 14. Find the common difference. Make sure you pause the video here and try it for yourself, but I'm going to do it a little bit faster this time because we already did a few examples. So to find the common difference, D is going to be U2, for example, minus U1, which is going to be 6 minus 2, and that's going to be equal to 4. So that's 4. Find the 10th term in the sequence. So U10 is going to be U1 plus 10 minus 1 times D. And my U1 is 2 plus 9 times D is 4. So 2 plus 36, that's going to be 38. And the last one, find the sum of the first 10 terms. So S10 is going to be, I already know my U1, so that makes my life easier. So I'm going to say 10 divided by 2. U1 is 2 plus U10, which is 38. So 5 times, what do we have here? 40. And that's going to be 200. All right, so that's it for arithmetic sequence and series. Hopefully you learned something. Make sure you check out other videos regarding sequence and series, and I'll be dropping another video which is full of just the examples, no theory, just the examples, and make sure you check that out as well. If you have any comments and suggestions, please do mention them below, and subscribe for more. See you later.